I'm sure a lot of you are wondering why you need to do mixed effects. Well, let me give a little background of statistical history and linguistics. In 1974, Settergren and Sankoff developed a program they called VARB-RULE, which is basically logistic regression, but specifically designed for sociolinguists. And it really was great because it made logistic regression freely available in a nice, easy-to-use format, and it became the standard in sociolinguistics. And there were newer versions, GoldVarb and GoldVarb X. But if you try and publish a paper now with VARB-RULE, you're going to find that editors and reviewers insist on using mixed effects. And you can use the newest instantiation, ARB-RULE, because that does mixed effects. But are you wondering, is mixed effects just the newest fad, just the newest thing? Or is there another reason that people are insisting that we use mixed effects models? So why mixed effects? Well, it's not because it's something new. It's actually been around for a long time, but early PCs were just too slow and had too little memory to run mixed effects models because they really are computationally intense. And so we just kind of pretended it wasn't all that important. One way we got around it was by doing by subject and by item analyses, which, by the way, most reviewers and editors won't accept nowadays anyway. So mixed effects models are the thing, not because they're a fad, but because they're computationally possible now. And if you've had some experience with them, you'll find that mixed effects models, even on a fast new computer with lots of memory, can take a long time. And by the way, if you're ever reading literature and it talks about hierarchical or multi-level models, they're the same thing as mixed effects models. So when do you need to use a mixed effects model? The short answer is whenever participants give more than one response. This is often called repeated effects. So if there are repeated effects, you need to use a mixed effects model. So let me give you an example. Let's say you give a language proficiency test to 4 different groups, and you want to know what the difference between the groups are. Each participant only gives one test score, so there are no repeated effects, and mixed effects models aren't needed. Let's look at another case. Say you're looking at the use of like observed in various contexts. In your recordings, you find that people use several different instances of like. In this case, you need a mixed effects model. Let me give you an example. Let's look at a study where reaction times are given to some sort of stimuli like words, and participants give many different responses to different words in the experiment. And let's say that gender is one of the independent variables. Okay, so before coming to the study, one male has a double latte. All right? So his response times are really fast because he's highly caffeinated. Well, that would tend to push the male average response times lower. Now, without mixed effects, the conclusion is that males are faster. But mixed effects models control for individual oddities like the caffeinated male, and it keeps him from being skewed by the particular oddities of one or more individuals. Now, sometimes individual test items are a little bit odd also, and that's why it's pretty typical to include a random effect for test item as well. So what exactly is a mixed effects model? It's mixed because it includes 2 different kinds of effects, fixed effects and random effects. Now, fixed effects are what you typically think of as independent variables. They're the things that we wonder how they affect the dependent variable. Random effects are variables that may influence the results, and they're things like oddities in particular individuals or test items. But we really don't wonder how random effects influence the dependent variable. We just want to control for their effect. So how do we control for the influence of random effects in our study? Well, you just add a random intercept or a random slope to the model. It's as simple as that. Let me give you an example from how this is done in Jamovi, and other stats packages are similar. So you put the dependent variable in the dependent variable box, and the independent variables, which are the fixed effects, either go in the factors box if they're categorical or the covariates box if they're continuous. And here's the only real difference between a mixed effects model and a model that's not a mixed effects model is we need to specify the random effect. So in the cluster variables box, I put participant and word. And I also need to define the random effects here. So there are two types of random effects. There are random intercepts and random slopes. When is each one needed? Well, random intercepts control for the influence of individual participants or test items, and they're needed if participants, for example, give more than one response. Random slopes control for the influence of individual participants by test item, for example, and they're needed if, for example, participants give more than one response to the exact same test item. You can think of it as an interaction between participant and test item. Let me give you an example of when random slopes are needed. So say you've got an experiment that measures reaction times to words, and reaction times to the same word is measured more than once. And let's say that one test word is tensile. If one participant is a structural engineer, tensile is a common structural engineering word, and that participant's response is going to be faster as a result. So including random slope participant by word controls for this kind of thing. So in sum, mixed effects models aren't a fad, they're not going away, and the reason they're used now is because computer models make them possible, and they really are needed if your participants give more than one response. And it's pretty simple to run mixed effects models, especially in Jamovi.